Good morning, class. This is Mr. Woods. And happy Monday to you, April 13th. Miss all of your faces. Hope you guys are home safe, doing well. I want to give you a quick review on the multi-step equations we worked on before the end of the year, before you guys left for home. And then I'm going to give you a couple of examples of the new equation. You're going to be working with special case equations that have infinitely many solutions and no solutions. So let's just real quick review some of the first steps that we learned in terms of solving multi-step equations. If I have this equation here, 3x plus 4x minus 2 equals 5x minus 3, okay? First thing we got to remember we do is we put the teammates that are on the same side of the equal sign, we combine them. That is what we call combining like terms. These two teammates have x's and they're on this side of the equal sign. They're teammates. 3x plus 4x makes 7x. Bring down my minus 2. Bring down the 5x minus 3. So the first reminder is when we combine like terms, when we have terms that are on the same team and equal and on the same side of the equal sign. Now we have teammates opposite of the equal sign. And recall, we call this one up here Lakers, Clippers. Put the Lakers together, right? And then we put the Clippers together. Now, once we have it in this form, we call this one Dodgers and Angels. Get them in the right dugout. Remember, this was the dugout. They're in the wrong dugout. We got to get them in the right dugout, which is the easiest one to move. We're going to move 5x to both sides. Now it eliminates that, creates a zero pair. Now that's gone. Now I have negative 3 on this side. I still have the negative 2 here. 7x minus 5x is 2x. Now I have all the Dodgers in the right dugout. Now I need to move the Angels. So I'm going to move the Angels by adding 1, adding 2 to both sides. That eliminates that, creates the zero pair. I'm left with 2x equals negative 3 plus 2 is negative 1. And then we would divide by the 2, and we'd find that x is equal to negative 1/2. Okay, so that's a quick reminder of Dodgers and Angels, Lakers and Clippers, combining like terms, getting them in the right dugout, okay, proper dugout. Also, don't forget we talked about and we learned the distributive property as well. So let's just take this example. 6 times negative 2x plus 4 is equal to 2x minus 3. Again, when we see parentheses, we know that this is the distributor and he's distributing multiplication to each term inside of the parentheses. So 6 times a negative 2x would give you a negative 12x. 6 times a positive 4 would give you a positive 24. Shout out to Kobe Bryant. 2x minus 3. So don't forget about how the distributive property works, okay? Now once we get to this portion here, Dodger, Angel, get them in the right dugout, correct? And we can do that by doing multiple things, okay? We could either add, doesn't matter which dugout you put them in, I could add 12x, I can subtract 2x, I can subtract 24, I can add 3. The whole point is, remember, we need to isolate the variable, get the variable by itself, isolate the variable. So I won't continue with that, but I just want to remind you about the distributive property, combining like terms, Dodgers and Angels, Lakers and Clippers. Go Lakers. All right? Now, the special cases that you guys are working on right now with the assignments that I gave you for this week. Sometimes in math, the answer isn't just, plain as day and right there. The answer isn't just one answer. Sometimes we solve equations and we find out, guess what? There's no answer to this equation. This is just weird. It doesn't look right. There's no solution. Okay. Other times we look at it and we're going, well, I could put any number in there just about and it's going to be the same thing. That's when we have infinitely many solutions. So let me see here. You're going to give you an example. So this is the first one. Let's go with 2x. And I put these in your Cornell notes, but we'll just talk about them. 2x plus 4 minus 5x is equal to negative 3x plus 10. So here we have a multiple step equation, right? I first noticed I have two teammates on the same side of the equal sign. I need to identify them as teammates and combine like terms. 2x minus 5x gives me a negative 3x. I don't have a teammate for the positive 4, so I'm going to bring that down. Plus 4 equals negative 3x plus 10. So now I notice, okay, I have Dodger Angel this side, Dodger Angel that side. I need to get them in the right dugout. Who do I want to move? And which dugout do I want to put them in? It does not matter. Choose whichever dugout you want them to be in and put them in there, as long as they're on the same team. So I have a negative 3x here. I'm going to add 3x, and I notice by doing this right here, by me doing this here, negative 3x plus 3x, well shoot, that creates a zero pair. That's 0. All I'm left over here is with the positive 4, right? And if I did it over here as well shoot, that's a 0 pair as well. That creates a 0. And all I'm left with is over here is that plus 10. Well, 0 plus 4 is 4, and 0 plus 10 is 10. But that don't make no stinking sense. 4 can't equal 10. That don't make no sense. Guess what? This is when we have no solution. Okay? This is when we have no solution. When this happens and we work it all out, and what's on this side of the equal sign does not equal that side of the equal sign, there's no solution to that multi-step equation. Okay, one more example here. Now, what happens when this happens? So let me write this example down. We got 3 times x minus 2 equals 3x minus 6. So I look at this and I see the parentheses, and I know that I have to multiply inside the parentheses and distribute multiplication to each term inside of the parentheses. And remember, there's 2 terms in here, 1 and 2. So 3 times x, I get 3x. 3 times a negative 2, I get a negative 6. I bring the rest down and I look at this and I go, what? Something isn't right here. They're identical. I have an identical equation to this side as I do to this side. So what does that mean? That means I could put any number in. I could put 100, I could put 1,000, I could put a gazillion, I could put a quadrillion, gazillion, tillion, billion, gazillion. You know what I'm saying? I could do anything and put the number in here, and it's going to give me the exact same answer here as I put here. Okay? Or I can continue to work it out and watch what happens. Okay, I have a 3x, so I'm going to subtract 3x to both sides. Whoop, 0 pair. That's 0. 0 pair here. That's 0. What does it leave us with? Negative 6 to both sides. So guess what? I'm going to get rid of the negative 6. I'm going to add 6. Guess what I just did? 0 pair again. 0 pair again. 0 is equal to 0. That tells you no matter what number I put in there, I'm going to get the same thing. When we do this class, this is what's called infinitely many solutions. In other words, shoot, man, I can get any number in there. I'm going to get the same, I'm going to get the correct answer. It doesn't matter what I plug in. So those are the 2 special cases you're working with this week. Infinitely many solutions and no solutions. Again, happy Monday. This is Mr. Woods saying Woods out. Peace.